Welcome, my name is Spyros Zigouris. I am a computer science professor and you are on videolearner.com. Through this channel you'll find complete lessons and explanations for the International Baccalaureate Diploma Program in Computer Science. Hi again, today we're going to explore the core architecture, either about GPU or CPU, and understand why it matters for modern systems. An element in the core architecture of a CPU is the instruction set architecture, ISA, that works as an interface between the hardware and the software. That's why it's in the middle, between hardware and software. In hardware sector are included layers like physics, devices that means transistors, gates/registers, and microarchitecture until the interface of ISA. Now in software are included layers like machine code, assembly language, programming language, algorithm, and in the upper layer, application. Now as you can see, all this structure defines the fundamental operations a CPU can perform. Each instruction in an ISA specifies a particular operation involving arithmetic operations, data movement, logical operations, control flow changes, or system interactions. Unique to CPU are specific types of instructions such as system management instructions and complex branching instructions. Just remember that in CPU cores we have single instruction and single data architecture, that is a sequential computer architecture where one core processor executes one instruction at a time on a single data element. On the other hand, GPUs include their own ISA. The instructions they provide focus on heavy arithmetic operations and rapid data movement, with fewer complex logic or control-oriented operations than those found in CPUs. This design reflects their priority on high throughput rather than broad task flexibility. Their instruction sets also include operations optimized for graphics rendering and large-scale parallel processing, including items listed below. SIMD instructions allow a single operation to be applied simultaneously to a large set of data, which is ideal for the parallel nature of graphics processing and certain types of computational tasks in scientific computing and deep learning. Note that an SIMD is executing the same instruction on different data across many cores. Texture mapping and manipulation instructions. Essential for graphics processing. These instructions handle tasks like pixel interpolation and texture fetching, which are important for rendering images and videos. Note again that texture mapping, for example, is applying a 2D image texture to a 3D model surface. And manipulation instructions, for example, is when an image is resized, zoomed, or scaled. That's all for now with core architecture. In the next lesson, we will deal with processing power. Bye bye from Spyros Zigouris and videolearner.com.